We're full. That's one of my favorite Far Sides. You ever seen the little Far Side commercial? The little, you know what I'm talking about? It shows the classroom scene. Teachers up at the board doing stuff. Yeah, the one they show all the people. You know, one person has this little bitty tiny head, right? And the person raises his hand and says, "I'm full. Can I go now?" I've had enough. All right, so we have more. We have 2.5 more hours of math. All right. So the slope of a line. So we're in a new section, 4.4. How do you find, now we want to talk about steepness. That's what slope is. And they spelled it right in this section. Slope, steepness. The steepness of a line. Before I get into all the formula and the details, just think with me for a second. Realize the more we can make this real, the more I think it'll stick with you. How would you do steepness? Right? Like you don't math. Well, in fact, maybe I should say this: is math real?
Yes. No.
Yes and no. Yeah. Is math real?
No. Oh no, it's just the truth.
So the truth is not real?
It's a made-up system that stops people from graduating.
And it's not, that's its purpose. How about this? To answer the question, what if I said, "Hey, on the way to class this morning, I saw it. I saw -3. Or no, it's 3. Let's just do +3. I saw 3. Out on the way to class, there it was. I saw 3. You guys would think, what do you mean you saw 3? You saw like 3 people or 3 cars? Or no, I didn't see 3 people or 3 cars or 3 objects of any kind. I just saw 3. And you think, what? What do you mean? You saw like the number 3 spray painted on the wall? What do you mean? No, I didn't see the number 3 written anywhere. I didn't see 3 objects. I just saw 3. You would know I'm ready for the padded room, right? So you can't. So my point is, no, math is not real. Math itself, the very essence of math is not real, right? It's made up. It's all in our heads, right? What are we even doing here then? I'm not supposed to let this secret out, right? I mean, what? Class over. Don't tell the dean I let this out. No. Math itself is not real. It's made up to describe things that are real. So it itself is made up. So if I did see 3 cars in a head-on collision at McKinley and Blackstone, I come to class and say, "Hey, I saw 3 cars out there in a head-on collision at McKinley and Blackstone." You know the concept of 3-ness. I know, in my head, the concept of 3-ness. So we can communicate about things in the real world that involve 3-ness. So math is made up to describe things that are real, right? So that's the place of math. So why am I saying all that? How do they describe slope, steepness? We all know if you have a road or a roof on your house. Let's just do a house, right? You can have like a roof that steep, or you can have a roof less steep, or you can have a roof really steep, right? You can have more and less steep roofs. We all know there's like a steepness kind of thing. But how do you put numbers to that? How do you do that? How would you do that? Because people need to do this in the real world, right? Math is made up to describe things that are real. We need to. For one of the clearest ways is sound. Right? We need something for sound, don't we? How loud things are. For example, if you have trouble hearing, you go to the doctor, and the doctor, you're getting older, and your doctor says your hearing's going, and you work in a machine shop, doctor's going to say, you can't buy that equipment anymore. You know, I'm going to write you a prescription that says you can't be next to that loud equipment. You have to be in a quieter area, or it's damaging your hearing. You take it back to your manager at work, and you say, here's what the doctor said. I'm not supposed to be by loud noises. Well, how loud? How loud is damaging? How do we know that? Well, we made up a number system called what? Decibels. We made that up. Sounds don't say, hey, I'm 23 decibels. We made that up based on the energy level of the sound. We made up a number system. We used math to describe things real. Why? Because that's useful. Otherwise, how would your doctor tell you, and how would he communicate to the manager? What would he do? The doctor would say, okay, here we go. I'm going to tell your manager not to buy anything this loud or louder. Do you got the this? Wait, one time. This? No, doctor, little this. Okay, got it. Go back to your manager. Try to say it all night to your manager. Doctor's this. That's just not going to work, right? It's a bad way to communicate. So we made up a number system called decibels. That's just one example of how math works in the real world to help us deal with things that are real. Math's made up. We made up the decimal system to describe things that are real. Same thing with roofs and steepness. When they build roofs, when they make roads, what do they call the steepness of a road? The grade. The grade of a road, right? If you I went to Cal Poly after my 3 years of junior college. I went out to Cal Poly, and as you come, my daughter's going to start Cal Poly in the fall. I already told her about the road. You come into Cal Poly, there's this really steep road, and then you drop into the beautiful Central Valley there by the beach and everything. But that road, the students all call that road, it's just super steep, the grade for double reasons, right? You're coming into Cal Poly, and it's hard to get good grades there at Cal Poly, and then that road is super steep. So they call that the grade. Everybody says, I was coming up the grade, and that's just what they talk about. So the grade, but it's just steepness. What do they call the steepness of a roof? They have a special name for steepness of a roof. Pitch. Ever heard of that? Roofers call it the pitch of the roof. It's all just slope, right? It's just fancy words for slope. Grade, pitch, steepness, slope. That's all what it is. Okay, so how do we put numbers to it? How do we do that? Because we need to, right? Roofers need to communicate to each other. People that build roads need to talk about how steep something is and what that means about cars and everything. So, real life, we need to deal with the idea of how steep something is. So, what kind of numbers could they make up to do that? Let me present one way, and you tell me what's wrong with it. What if they said, okay, I'll look at a roof, and I'll just say, well, if the roof, if the roof goes up, right, goes up, I don't know, 5 feet, whatever. I'll say it's a 5-foot roof. It's a 5-foot steepness, 5-foot slope. Would that be a good system? Would that really communicate the real-life idea of steepness? No, it wouldn't, huh? Because here's the problem. You could have a roof that rises 5 feet like that. Okay, here, let me change it a little bit. Let me be dramatic so it's really clear my point. You could have a roof that's going to go all the way from here to here, like that, and it's going to go up in that time 5 feet. And you can have another roof that goes from here to here that also goes up. So, yeah, they're both 5 feet roofs. This one, you're telling me, is the same steepness as that one? No way. So we can't just say how much it goes up. That's not going to give the real life thing that we all feel. We all sense there's something there about steep. We all sense this one's more steep. If you're a little person, standing on this one, you'd really feel that one's more steep than if you were standing on that one, huh? So steepness is more than just the rise. How much it goes up. That alone won't do it, will it? So we don't just have one number to communicate steepness. What else do we have to give?
How long it takes.
Yeah, how long it takes it to get there. We call this distance the run. And both are important, aren't they? The rise and the run. The sideways movement, which we call the run, the sideways movement, how long it takes you to get there, and the rise. Both are factors. So in other words, if it takes you like 10 feet, or if it takes you 1 foot, or let's say 2 feet. Slope, steepness, comes from the idea of rise over run. It's how fast it gets higher. That's what steepness is, huh? When you're going up a steep mountain, you're driving up into the mountains, right? And you keep seeing those signs, 6,000 feet, 7,000 feet, right? You're getting higher and higher, and those signs are coming quick. You're climbing quick. The faster your height changes, the rate of change of your height. So what we do for slope, it's rise over run. So it's 5. This one would be 5 over 10, which is just a half if you reduce that fraction, right? This one, this slope, rise over run. Rise over run. That is what we made up for. Rise over run. Be 5 over 2. See, that's much steeper than 1 over 2, isn't it? See how that communicates the idea of steepness? It's rise divided by run. It's how fast you go up, how rapidly you go up. So when you divide by the run, you get the steepness, something that feels like steepness. So that's steeper. 5 halves is bigger than 1 half. This is steeper than that. So that's it. That's the definition they came up with slope. They're just fitting real life to numbers to real life. is what they're doing. So, with all that, let me give you so that's all the backdrop. Let me give you the actual way we crank it out. So slope, steepness is rise over run. It's how much something rises divided by how much it goes sideways. The vertical over the horizontal. That's steepness. So, what does that mean about my points? Let me put these 2 points on the graph. 2, 5, 1, 2, 1, 2, 3, 4, 5. So here's one of them. Over 2, up 5. And the other one is over 3, up 4. There we go. Over 2, up 5, and over 3, up 4. We good there with those dots? Now we want to think about the line connecting those two. There it is. It's a tiny little line. And the slope of that line. We want the steepness or the slope of that line. First off, that line's going down to the right. So guess what its steepness is going to be? Negative. It's going to be something negative. As you go to the right, if you go down, you're negative steep. If you go up, you're positive. Jose.
How do you figure that it's going down instead of
Yeah, good question. Because if I say, hey, this thing's going down, someone would say, no, it's not. Not if I'm going up that way. Huh. So really, every mountain goes up and down. Good point. Right? Everybody see Jose's point? He's right. It just all depends which way you're going, huh? Right? If you go that way, you're going up. If you go that way, you're going down. So why do I call this down? We commonly agree, you're going to need to agree, that as we go to the right. It's always as we go to the right because of that very problem. So we never go left. We say, don't do that. Don't go left. Go right. Yeah, so when we say up or down, we mean as you go to the why right? Because that's how the positive x numbers go, 2, 3, 4, 5, 6, 7. Whereas these ones are negative, so we don't go that way. So we just say as you go to the right, does it go up or down? Good point, Jose. All right, so this then, as we go to the right, that little piece is going down. Okay, so we call that, it's going to be a negative slope. So anyway, so how do we actually calculate it? Well, we just said it's rise over run. How do we get rise? Rise, that's like from here to here, isn't it? See how it's the two y values subtracted? Do you see that? That's how you get the rise between 2 points, is you take this one's height and that one's height, meaning they're y, right? Because remember, it's x first, then y. X first, then y. Remember how the two numbers work? Right? So you got to subtract the two y values, don't you? Right? Let's call this one x1, y1, and this one x2, y2. And those are subscripts. I'm just putting those numbers down low, called a subscript, just because I'm saying, hey, this is the first points, x and y. And this is the second points, x and y. Right? The first point they gave me was 2, 5. So I'm calling his x and y, x1, y1, and his x and y, x2, y2. Is that good? Like that? So x1, y1, x2, y2, like that. We're connecting those two, like that. Okay? So now, how do I find rise? How do I find how far it is from here to here? That's my rise. Well, I got to take the two y values and subtract them, huh? y2 minus y1. In other words, I got to take 4 minus 5. I got to take this y value minus that y value. 4 minus 5. And that's going to be the top. And that'll be negative 1, meaning that line goes down 1. That line, as we go to the right, remember, it's always as we go to the right. So if you're going from this dot to that dot, you drop 1, don't you? You go down from a height of 5 to a height of 4. You rise negatively. You go down 1. Is that good? You go down 1 from 5 to 4. So you take the second y value, the ending y value minus the beginning y value, 4 minus 5. Now, what about the run? Well, it goes from 2 to 3. The sideways movement, the run. This is the run. This is the rise. So the run, the sideways movement, what's that? How do you find out how sideways? Well, 3 minus 2. which is x2 minus x1. You subtract the two x values, don't you? That's how you get how far sideways it goes. You subtract the two x values of those 2 points. Does that make sense? So that's 1. 3 minus 2 is 1. Simplify that fraction, it's just negative 1. Too quick on that? So this is the formula we're going to use all the time. Slope is rise over run, y2 minus y1 over x2 minus x1. Because rise is the difference in heights, and run is the difference in sideways positions. X values. And everybody okay with this last step when I simplified the fraction? Remember, 1's in the bottom, we always ignore. So I just ignored it. Right? Because to divide by 1 doesn't change anything, does it? You with me on that?
Or 1. Always.
The only lonely number, huh?
So
Julio.
I see 2, and 5, and then 3 and 4 right there. I want to do like 5 minus 4, but you swap them that way. You go 4 minus 5.
Right. You do the y2 minus the y1. The second y value. Minus, technically, Julio, you could do it the other way as well. The formula does it, but you have to turn them both around. It'll actually work. Let me show you real quick. You could do the 5 minus the 4. But if you do that, if you start with this guy on the y's, then you got to start with this guy, 2 minus 3. So that means you got to be consistent. So if this is your starter, start with him on the top and the bottom, and it'll be okay. 1 over negative 1. See what that is? Well, still 1 negative. Negative 1, same answer.
Cool.
It actually works either way.
All right.
Yeah, you can just pick either one to be your starter. But then be consistent. Don't change your mind halfway through. Yeah, and you'll be good. So that's how we do slope. Rise over run. All right, let's try another one. It's easy to mess up with all them negative signs. I wish they wouldn't do that in the very next problem. All right, so they're giving me this point. But we don't need to graph it. I just did all that to give you the backdrop. Let's don't. Let's just go, look, you want slope? Slope is rise over run. Rise is y2 minus y1 over x2 minus x1. So all we need to do is crank out that formula. Rise is the difference of y values over the difference of x values is run. Rise over run. And let's take the minus 7, minus 10 minus 1. This is x1, y1, x2, y2. Good to there? So try. Now watch out. There's a couple of there's subtraction symbols that are part of the formula. That's going to be in addition to any negatives that you plug in. So you get some double negative action, right? And that becomes positive, right? They're throwing a lot of negatives in this one right away. So y2 minus y1 over x2 minus x1. Let me hold up there for a minute. Everybody see what's going on there? Right, so we have the black negative signs, which are part of the formula, the subtraction symbols, right? And then I plugged in the y2 minus y1, x2 minus x1. Good there. Good so far. And then the negatives head-to-head, positive, right? So these two will become positive, and these two will become positive, won't they? So we get negative 1, negative 10, 7, and positive. That good to there? And then that answer is what? 6 over negative 3, which equals negative 2. We're done. Did you track with all that? Lot of negative signs there. How are we doing? Anything I can answer? Does that make sense? So in the end, our answer came out negative 2. The steepness, the slope, is negative. So is that a line that goes up or down to the right? Down, negative. So this line must be, if I was to graph it, it must be going down. If I was to graph this point and this point, put them on an axis and all that, I would find out the points go like that. It goes down to the right because the slope came out negative. Anyway, I'm not going to mess with it. Questions on that one? Is that good? We see how I got that answer? We can handle it. All right, let's try this one. So we got -1, -19, and -11, -20. This is x1, y1, x2, y2. So what's the slope formula? Rise over run. And rise is y2 minus y1 over run, x2 minus x1. Rise over run. Take it from there. Same kind of thing. So y2 minus y1 over x2 minus x1. Good like that? All those negatives, including the subtractions in the middle. You know what that does, right? The double negative thing. And so what is that? -1 over -10?
Yes.
So what do the two negatives do? Yeah, they cancel. Even though the 1 and the 10 can't cancel, the two negatives do. Two negatives are gone. They become positive. It's positive 1/10. Is that good? Questions on that one?
Only if the top and bottom number are negative, you turn it into a positive?
Right, because two negatives, right? To make positive. Yeah, if we just had one negative, like if just the top was negative or just the bottom, the answer would just be negative. But because one negative is just negative, but two negatives is positive. Good there, no questions? All right, I'll keep moving. slope equals y2 minus y1 over x2 minus x1. Okay, so this is x1, y1, x2, y2. Give it a try. Something funny is going to happen. See if you know what that means. Let's say, are we good to there? Does everybody see what's happening? So the double negative thing. Does that make sense? So I put in the two y values on the top. Now that the two negatives right here are going to become positive. So that's 0, over negative 10. Right, the bottom is, you lose $6, you lose $4, you lost $10, right? Okay, so what is 0 over negative 10? What's 0 in the top of a fraction? What's 0? If I said I had 0/3 of the pie last night.
Yeah, 0.
I had no pie. That's just a weird way to say 0. 0 in the top is just 0. What if the 0 was on the bottom? Would that be 0 also? What's that? Undefined. That's different. Now, that's not what we have here, but it's probably the next problem. Does that make sense? You know that difference. They're key in that you know that difference. 0 underneath, here's how I help people remember it. Underneath is undefined. What do we mean undefined? We mean there's nothing in the real world that does that. You have no connection in the world. You can have 0/3 of the pie. That's just a weird way to say no pie. But you can't put 0 on the bottom. What does that mean to cut the pie into 0 pieces? You can't do that. You don't touch it. It's one piece. How do you cut a pie into 0 pieces? That's impossible. So when we say undefined, we mean there's no connection to the real world. That's just ridiculous. So 0 underneath is undefined. So it's a big difference to have 0 on the top of a fraction or 0 on the bottom. Does everybody see that? All right, so I'll erase this, though. This one is not that. Get rid of that part there. All right, so let's move on. Oops. There you go. Okay, so try that one. Find the slope between those two. x1, y1, x2, y2. Slope equals the difference of y values over the difference of x values. This is rise over run. Rise is y values, run is x values. So Am I going too quick? So y2 minus y1 minus 9 minus 8 over 6 minus 6, huh? So that's minus 9 plus 8 over 0. That's minus 1 over 0, which is undefined. So that's different. That one doesn't equal 0. It equals undefined. Everybody see the difference? There's a difference between 0, an answer of 0, and an answer of undefined. Good on that? What kind of line is that, by the way? What does that look like?
It's a straight vertical.
Is it vertical? Is it straight up and down?
Undefined?
Yeah, undefined, this one. Is it? How do you know?
Because the x is
Good, good. Yeah, I like what you're saying. Rise, I like how you're thinking, Alex. You're thinking about that. Remember, slope is rise over run. So if the bottom is 0, that means the line doesn't run. What kind of line doesn't go sideways? A vertical line. That must be, so undefined slope is a vertical line. Does everybody see that? If you have an undefined slope, that means you must be a line that goes straight up and down. How do I know that again? Because you're undefined when 0 is in the bottom. And what's the bottom? It's your run. Remember, slope is rise. Slope is rise over run. So if the bottom is coming at 0, which is what makes the answer undefined. 0 underneath is undefined. So underneath is run. So what kind of line has run is your sideways movement. What kind of line has no run, no size 0 sideways movement? Perfectly vertical line. It doesn't go sideways at all. Does that make sense?
Can you do that in the graph?
Yeah, it will be a perfectly. If we were to graph now, if we were to graph those two dots, yeah, we can do that real quick. That's what Alex was noticing, and he is right. Let's graph it. You don't have to. It's not required at all, but I'll do it. So over 6 down 8. Right? Remember, first number's over, second is up down. Right? Over 6 down 8 over 1, 2, 3, 4, 5, 6. 1, 2. Oh, down 8. 1, 2, 3, 4, 5, 6, 7, 8. So here's the dot. Over 6 down 8. Where's the other one? Over 6 down 9. Right there. See the two dots? What kind of line is going to connect those two dots? Perfectly vertical. See, they're both over 6. They have no sideways movement. That's what Alex was noticing. They're both over 6. They both have the same x numbers, don't they? So they're both over the same amount. They're lined up vertically. So slope is rise over run. This has no run. No sideways movement. That's why the slope is undefined. 0 underneath, undefined. Good on that? Is it all coming together for you? These little graphing things? Because they will ask that in a minute. They'll suddenly throw out a slope. They'll go, undefined slope. What kind of line is that? You got to know, oh, that's vertical. Right? They'll do things like that. Is that good? Can I flash back now? What if 0's in the top? Let's flash back to that one we had a minute ago where we had 0 in the top. So this one's 0 in the bottom of the slope. That's underneath undefined, vertical. Let's go back now. Here we had 0 in the top. Notice. Remember, it's rise over run. And we got an answer 0. 0 in the top is just 0. You can have 0 tenths of the pi. 0 in the top is just 0. But what kind of line is that? If I was to graph it, what would it look like when you have 0 on the top? We already know 0 underneath is a vertical line. What do you think 0 on the top is? Horizontal line. And you know for sure because it doesn't rise. No rise. What kind of a line has no rise? Perfectly horizontal line. So whenever you have 0 slope, it's a horizontal. Like the horizon, you know, sideways? It's a horizontal line. Because you don't rise. That's the only kind of line that doesn't have any rise at all. You can see it if we graph the points. Let's do that again real quick. Where is it? Yeah, so if I was to graph the points. Over 4, remember the first number's over. Second number's up, down. So over 4, 1, 2, 3, 4, down, 1, 2, 3. So there's over 4, down 3. The other one is back 6. 1, 2, 3, 4, 5, 6. Back 6, down 3. Back 6. This is back 6, down 3. This one's over 4. See the two dots? If I was to connect those two dots, see what I'd get? Horizontal line. No rise. 0 rise, 0 on the top is just 0. So, what they'll throw at you in just a minute is they'll go, da-da-da, slope is 0. What kind of line is that? And you need to know, oh, it's a flat line. Because it's got slope 0 means flat, horizontal. And they'll go, oh, slope undefined. What kind of line is that? Vertical. Because 0 underneath is undefined, and that's the line that has no run. That's a perfectly vertical line. No sideways movement, no run. It'd be good to put those two on your 3x5 card. Be good to have slope 0 horizontal, slope undefined vertical, right on your 3x5 card. Be good to have those. Is that good? Questions on that? All right. I'll move that ahead.
I had to say it. If slope equals 0, then it doesn't rise to the occasion.
It doesn't rise, okay? If slope is 0, there's no rise at all. All right. All right. Determine the slope of the line shown at the right. All right. Can you find the slope of that line? So now they're just giving us a couple of dots on the graph. They're not actually giving me any coordinates. So let me let you try. Rather than me jumping in and doing something. Remember, slope is rise over run. So think about from this dot to that dot, right? The two dots they're clearly showing me. Can you tell how much the rise and how much the run are between those two dots? So go ahead and try that. I'm messing it up there. So between those two dots, you can find the rise and the run. So, from this dot, I go up 1, right? And over 1, 2, 3. Up 1, over 3. Done. Does that make sense? It rose 1, went over 3. Rise 1, run 3. Rise, run. 1, 3. Remember, rise is vertical movement. Run is sideways. This is the run. This is the rise. So again, it goes up 1 and over 3. Rise over run. Is that good? See how I figured just by counting the jumps. First I went up, then I went over. Just count the jumps. Is that good? Questions on that? All's well? Julio?
So now these are positives.
Yes.
So now they're going that way.
Yes, exactly. Yeah. Now, what if it had gone down instead of up? That would have been negative. Or left instead of right. That would have been negative. Good point. Yeah. Julio's comment is a good one. Up is positive. Get my pen back here. Up is positive. Down is negative. Right is positive. Left is negative. Huh? So whenever we're moving and counting jumps and things, going up and right and left and down and stuff, remember, if you go up, that's positive rise. If you go down, that's negative rise. Yeah, this one happened to go up and right, so everything was positive. But in a minute, they're going to mess with us on that. Good point, Julio. So this one goes up, positive, right, positive, but they can go down negative, they can go left negative, huh? For the rise and the run movements. Good. All right. Let's keep going. Okay, so there we go. Try that one, same kind of thing. They want the slope, and you know slope is made up to be rise over run because that describes the real life sense of steepness. So start from the first dot, start from that one and go to that one and figure out how far you have to rise and run. So move from one to the other and count your rise jumps and count your run jumps. Remember, up and right are positive, down and left are negative.
You could also take those two coordinate numbers.
You could.
Do the math, right?
Yep, you could. That'd be a little more work though, but you could. Okay, so from this dot, I go down 1, 2, 3. That's down 3. And over 1, positive 1. Divide that, negative 3. Is that good? Now, you might be wondering, wait, can't we go to the right? Sure. I could go right 1. What would that be? Run 1. And then down 1, 2, 3. Same thing. Either way, you get from the first dot to the second, you're going to go down 3, so rise negative 3, and over positive 1, or over positive 1, run, and down 3, rise. Either way, negative 3. Does that make sense?
Or you can also, because that's what I was using. I was using the formula to find rise, which is y2 minus y1.
Right.
And that will get me the same answer.
It would. It's more work, though. I think it's easier if they give you dots on an actual graph, just count them. I think this will save you a lot of time. You're right. You could technically find the coordinates. Like I'll do what you're saying. You're right. You're saying find this point. What is that? That's over 0, up 3. Find this point. What is over 1, up 0. And now do y2 minus y1 over x2 minus x1. That's going to be, and this will be x1 y1, x2 y2, y2 minus y1, 0 minus 3 over x2 minus x1, 1 minus 0. So that's negative 3 over 1, negative 3. A lot more work. Right? And it's true. It's right. But way easier to just count the jumps. Now, 1, 2, 3, over 1. So if they give you an actual graph with dots, just count them. Save you a lot of work. Down 3, over 1. That makes sense? Rise over run. Now, let me point out this. This is kind of interesting, I think. Remember how we said we could reverse the points? The order doesn't matter? That's true here, too. I could start from this point. This one right here. You don't have to start from the higher one. You can start from either one. And just do the rise over run, and it'll work. Let's start here. Let's go up 1, 2, 3. Remember, rise over run. I just went up 3, didn't I? So that rise is positive 3. And then back 1. So up 3, back 1. That's negative 1 because I'm going left 1. So that's negative 1. Positive over negative? Same answer. Isn't math beautiful?
Yeah, but you can't start at the center. I tried to start at 0. You've got to start with 1.
Yeah, because there's not on the line. Yeah, we're jumping from point on the line to point on the line. Yeah, we got to have 2 points that are on the line. Yeah. Math beautifully agrees with itself, always, because it's a system of logic that just flows. As long as you make logical steps, it'll work. So it doesn't matter, what your style is. Start with this point, start with that point, do the coordinates, do the jumps, whatever. As long as it's logically true, it'll be true in the end. All right. So okay, try that one. Find the slope of that line.
Can you zoom in?
What's that?
Can you zoom in? Oh, but it's
Use the min?
Zoom.
Oh, zoom it in. Gotcha. No,
Yeah, now I read.
I don't want to. If I do, I'll get the other thing off the screen, the slope question. So let me let you think about it. Also, there's an answer without doing anything. If you remember what we said about 10 minutes ago. Yeah, you remember that. Yeah. So remember when it's perfectly straight up and down? I mean, you don't have to memorize everything perfectly. You can put it on a 3x5 card, though. Remember, slope is rise over run. And this line, he rises. What's his run? He's got no run. He doesn't go sideways at all. Right? So what rise, who cares, whatever. The run is 0. So what does 0 underneath mean? Undefined. Remember, vertical lines are always undefined slope. So the slope is undefined. Is that good? Straight up and down lines have no sideways movement. No run. 0 underneath. Undefined. What do we mean undefined? What does that mean?
Unlimited.
Yeah, that means that's so steep that a trillion is not big enough. It's perfectly steep.
It will never gonna cross anything.
Yeah, it's just perfectly straight up and down. It's infinitely steep is what that means. It's perfectly steep. There we go. All right. Okay. Find the slope of that one. You can use the points, but why bother? What do we know about the slope of lines that go perfectly? So it's rise over run. Just always remember, slope is rise over run. How much does that line rise?
0.
No rise over. Who cares what the run is? When 0's in the top of a fraction, it's just 0. Right? You have 0 thirds of the pie. You have 0 tenths of the pie. You have 0 fifths of the pie. You had no pie. However you want to say it. That pie was cut into 3 pieces and I had none. Oh, it was cut into 10 pieces and I had none. It was cut into 5 pieces and I had none. Okay, so you had none. Right? Doesn't matter how you say it. You had no pie. 0 on the top of a fraction is 0. Real life. Right? Math is describing the real world there. So that's the slope 0. It's not undefined. It's 0. It's not infinite. It's 0. That's no steepness at all, in other words, right? So if you're talking with your friend on the phone about this upcoming weekend, and your friend says, hey, you want to go for a hike? And you say, sure. What would be the first question you'd ask your friend? You'd say, what's the slope, right? Isn't that what you'd say, right? It's just natural now for you, right? What's the slope, right?
How hard a hike?
Your friend would think, what's wrong with you? Too many math classes, you weirdo. What do you mean, what's the slope? Now, anyway, suppose you said, just play with me on this for a minute. What's the slope? And your friend said back to you, oh, the slope is undefined. And you thought to yourself, undefined. I said, what's he mean? What a weird friend. Undefined. Maybe he means like 0, I guess. What a big miscommunication that would be, huh? If your friend said undefined, what kind of slope is undefined? This is undefined, right? Undefined is infinite, right? And you thought 0, which is this. This is slope 0. This is slope undefined, right? So you thought you were going for that kind of a trip. You could just bring your flip-flops, right? But your friend said it's undefined, like you need ropes and special shoes and things, right? Big difference. So don't make that mistake in the test, right? Because they'll ask you slope 0, and I know students just kind of think they're all the same. Undefined, that's kind of like 0. No, it's exactly the opposite of 0. Infinite is a good way for, I don't know if you know the infinity symbol. That's the idea. That's the idea of undefined. It's infinitely steep, perfectly steep. It's the opposite of 0. 0 is flat. Undefined is perfectly vertical, right? They are the opposites. Put that in your 3x5 card. So it's not, and if your friend calls, and you be sure to get that straight. All right. I had a friend that used to hike all those kind of things. And there was no way I was ever going to go with him. All right, so crazy.
He's a dumb guy.
He's a dumb guy.
With a parachute on him?
No, he just climbed it. First time ever. Did you?
First time ever somebody did it with no ropes?
I wish I'd gone to Yosemite on Saturday.
Yeah.
Kind of scary to watch that.
Oh, yes, it would be. All right. Graph the line with the given point and slope. So, there we go. So, we have The line through -9, -7 with slope 5/3. Okay. That's weird. So how are we going to do that? This is kind of strange. They're changing the questions on us now. Are you ready for this? How are we going to actually do this? Well, let's before we even look at those multiple choice things, a graph of our own. Let's start with this point. -9, -7. Can we put that on the graph first off? Can you find that dot?
Yeah.
Okay, so the first number is over, second number is up, down, positive, up, negative, down. So the first number is over -9. 1, 2, right. 3, 4, 5, 6, 7, 8, 9. Good so far? Back 9. And then down 7. 1, 2, 3, 4, 5, 6, 7. So back 9, down 7. It's right there. Everybody good with that? There's the dot they're talking about. Back 9, down 7. Now from there, from that dot, the line, it says the line goes through that dot. It's some kind of a line that goes through that dot, and its slope is 5/3. Now 5/3, remember what slope is? Rise over run. So that means from this dot I'm going to go 1, 2, 3, 4, 5. That's probably over. My jumps are probably too big. Whatever. I'm not far from exact here. 1, 2, 3, 4, 5. So I'm going to go up 5 and over 1, 2, 3. Over 3. Does that make sense what I did? Rise over run. Up 5 over 3. So that leads me to a new dot, and then you know the drill from there. Connect the two dots. You got your line. Alex?
Can you simply add
Yeah.
coordinate?
Add the 5, add the 3.
Yeah.
And you get the coordinates, whether it be -4, -4. That must be this coordinate here. -4, -4. Yep, that works too. It's another way. I don't think that's easier, but that is also true. Yeah, I think the easiest way is just find the original dot and then just go up 5 over 3, because that's what the slope is. Rise over run, up 5 over 3. So which line is it then? Can you tell? Which A, B, C, or D? Yeah, looks like B, doesn't it? It looks a little weird because they just give you different perspective, but it's the only one that looks at all like ours.
And you get a little bit different picture when you draw yourself too.
Yeah.
Your line can be off.
Yeah, right. That's right. Is that good? Does that make sense what we do? So you just find the point and then go up 5 over 3. Rise over. So they're just really drilling home the idea that slope is rise over run. Rise over run. All right. So let's try that one. Okay. So same kind of thing. See what you can do. I bet you guys are getting kind of tricky. Try the same kind of thing as last time. Okay, so let's start with the point over 0, up 7, 3, 4, 5, 6, 7. Everybody good with that dot there? So that's over 0, up 7, right? First number's over. Second number's up or down. So over 0, up 7. We got that. Now, what do we do with that? I don't know. They use M for slope. It stands for some French word, mountainous. Some kind of... Anyway, so how do we take that slope now? And what's weird is we need two numbers, right? Slope is supposed to be rise over run. Good job. I knew you guys were tricky, right? Because remember how we've learned that doesn't change it? See how we do that all the time in math? We make things look different without being different, right? Divide by 1 doesn't change anything. That's still 3. And now we can have our two numbers. Yeah. I call that plastic surgery. We remove the wrinkles, but it's the same person, right? We do that all the time. Just saying a weird word to help you remember it. That's what we do all the time. If you kind of dial in with that, you'll see it all the time. All the time. Why? Why are we doing that? Well, because we need two numbers, right? But we can't change it. I can't just make it something it never was. So I make it look different without being different. So I put 3 over 1. That's still 3. But now it has the look I need. I need the two numbers for rise and run. Yeah, we do that all the time in math. All right, so rise over run, 3 over run. So now you know what to do, right? From the 0, 7, you rise 3. 1, 2, 3. Go up 1, 2, 3 over 1. And then you just connect the two dots. Does that make sense? I went up 3 over 1. Rise 3, go over 1. Up 3 over 1. Is that good? And there's our two dots.
Now, how do you know that that 3 is the second one that you need to you did 0, 7 first.
Right. Oh, I see. How do you start with that and not the 3? Because the 3 came first. I see what you're saying. Good question, Jose. Yeah. It's because the 3 is 3 over 1. That's just how far you move, not a where you start from. See if I can say that better. It's like, this is like a road sign. Slope is like a road sign. Like, what if I suddenly said a road sign? 27 miles to Yosemite. Well, from where? Right? So that's all this slope is. It's saying, go up 3 and over 1. Yeah, but from where? We have to start somewhere. So that's how I know I start with the 0, 7. So just like if they take a road sign, 23 miles to Yosemite. Yeah, but not from here. From where? That road sign has to be planted somewhere that then tells you, right? That's what a slope is. A slope is a road sign saying go up 3 and over 1. But I gotta know from where. That's what the 0, 7. So that's why we have to start with the 0, 7. Because once we're planted there, then from there, we go up 3 and over 1. Does that make sense? A slope is a road sign. Telling you how far to move. But it's not telling you where to start. It's just how far to move from the starting point.
I get a little bit confused on where from the first point where you go. I want to go over. I want
gotcha.
3 over to the right.
Yeah, 3 is rise. Remember, it's rise over run. Yeah, so you got to keep saying. And I'm glad you brought that up. Actually, let me point this out because you know why you're doing that. I think it's because that's how XY coordinates. Yeah. Let's take special note of that. They have reverse order, which is tricky, right? Does everybody see what Melody's noticing? When we do XY points, our first number is the over number. The sideways. When we have the two numbers with the comma right here, right? The X and the Y, the first number's over. It's sideways. But when we do slope, the first number, the number on the top is up, down. It's reverse. So be intent. And some students switch that around in the test, and it just decimates their test. So I say that to scare you a little bit so that won't happen. There's good fear, right? Like staying out of the, people wear the no fear hats. I know what they mean, but there's good times to fear. Like, don't play in the lion cage, right? That'd be stay out of the lion cage, for example, at the zoo. Right? There's appropriate fears. You should fear switching those. Because if you switch those, it'll just decimate everything. So be really clear. when you do the two numbers with the comma and the parentheses, the first number is over. Sorry, the second number is up, down. But slope is reverse. So keep saying to yourself, rise over run, rise over run. The number it's up, down on the top of the slope. Yeah, good point, Melody. I forgot. It's hard for me. I learned this when I was a kid, and I've taught it for 25 years, so it's just like tying my shoe. So I forget that people, they reverse those. That's right. I remember now.
So you're running over and you're rising up or down. Is that confusing?
If it works for you, great. All right. So so the over is first with the coordinates, and up is first with the slope. However you remember that.
So M just means the slope, right?
M just means the slope. It stands for some French word, mountainous something. I forget what it is. It's a lot of algebra was discovered by French people. Which is the only thing I respect about the French. So I don't mean to be harsh on them, but I'm listening to, I think I mentioned Winston Churchill's biography. So I drive around, I listen to, the French did horrible in World War II. I mean, the movies, I'm very excited about the movie coming out next month, July. Dunkirk, that's historical. That's when they rescued the British boys off the beaches at Dunkirk in the beginning of World War II. When Hitler pushed through France like hot knife through butter. It was nothing. The French surrendered in droves. They were terrible. They were lying to Churchill about how the battle was going. They were so embarrassed. They're like, oh yeah, we got the Germans. We got them in this one. Churchill would fly over and check, and they'd be getting wiped out. And so Churchill, send more troops. They were on in England to send more troops. Send more troops. The French were begging. And then so Churchill would check on him. All right, well, how's this battle going? He said, oh, no, we got him here. They would lie. Because they were embarrassed. That's so stupid. And then the Germans just went right through them, that whole thing. And so the English troops got trapped because the Nazis were piling through. The English troops got trapped there on the beaches at Dunkirk. That's what that movie's all about. It was historical. One of the biggest moments in the war. They were in the early war. They were trapped there. What was it, 300,000? It was most of the British Army. If the Panzers had gotten there and wiped them out, that would have been it for Britain early on in the war. Hitler could have easily taken boats across within the next year, landed in Britain and taken it. Because that was most of the British Army right there on the beaches of Dunkirk. And they didn't have enough boats. They didn't have enough war boats to get the boys across. All the 18, 19, 20-year-old boys. First in war, and they're shocked, and the Panzers are closing on them, and the Panzers were 3 days away, and England knew they were there, and they just didn't expect them to get through the French so fast. The French were so weak. The Panzers just pushed right through them, and they were trapped there, and they're like, oh man, we're 3 days from dead. And the English were like, we don't have enough boats to bring them across the English Channel, bring them home. We don't have enough war boats, and that's when all the dads got in their boats, and they just took their little trawler boats, their fishing boats. All the dads just went across the English Channel to get their boys off those beaches while the bombers were, the Nazis got their planes there in time, but the Panzers weren't there yet. Very exciting. They rescued like 80-90% of the boys, most of the English troops off the beaches, although many died to the sharks and the bombs and all those things.
So
but anyway.
Doing a field trip to see the movie.
That's right. I'm all excited about it. I'm so glad when I saw it. We were coming out of a movie maybe 6 months ago, and I saw the thing. I'm like, Dunkirk, kids, well, I'll pay for that one. We'll see that one, kids. I was telling my kids, because I'm always cheap. I know, like, what, we can rent it at home. Why do we need to go? Dad, I'll pay for that one in the movie. We'll see Dunkirk. It would be to see. I hope they do it pretty. It looks like they're pretty faithful to historical truth there.
It sounds like you like a history, Mr. Aaron.
I do like. I'm a wannabe history teacher. Yeah, I used to hate history in high school. Did I tell you that already? History was so boring. 1833, so boring. Then junior college. I went to junior college, and Mr. Maglieri, he brought history alive. It was people and events, and I thought, wow, that's really interesting stuff. What were those high school teachers doing?
Yeah, I don't know. I was the same way.
Were you?
I didn't like it in high school, and now I'm like, it's cool because you think about it, and it's like, this is what shaped our world.
Yeah, totally. Yeah, like if that Battle of Dunkirk, if the Panzers... Well, actually, it was one of the key mistakes Hitler made. They said Hitler made 3 or 4 crucial mistakes in the war, or it could have gone otherwise. He did not realize they were all trapped there at first. For a couple of days, Hitler did not realize that most of the English army was trapped there on the beaches, or he would have accelerated the Panzers to it. He just didn't realize it. He realized it a couple days late in the fathers got their boys off the beaches in time. So yeah, it would have turned, because it was most of the English army was there. Like 80% of the English army was there, and they were defenseless, trapped on the beach.
Who's starring in it, do you know?
I don't know. I don't know the people.
They had no weapons or guns?
No, they had weapons, but they didn't have tanks. I mean, the Panzers were closing on them. I mean, they were out in the open with Panzers and the beach on the other side. You know, the water on the English Channel, and then open ground and Panzers and planes. You know, so they were pretty much done. Little rifles aren't going to stop the Panzers or the planes. Yeah. Anyway, so I'm doing a history lesson. I'm here to teach math, so I will stay on track. I get excited about it. I'm a wannabe history too. They were really bad.
I just read something that Descartes never used M.
René Descartes, did he?
He never used M for slope.
Didn't he? Yeah, okay. I've never looked close at his. But he did come up with the Cartesian coordinate system. You're right, it's from him. All right, so we start with our point. Over 3 down 2. Over 3 down 2. So there's the little dot where we start, over 3 down 2. And then, now what do we do with that slope number? Yeah, and we put it over 1 because we're doing plastic surgery. We're making it look different without being different, because that helps us do the rise and the run thing. That's right. So from this dot right here, we go up, 2? 1, 2, over 1. Up 2 over 1. Does that make sense? Rise over run?
Not to the left.
Right, because that would be -1. Yeah, because right is positive, left is negative.
Okay.
Yeah, so up 2 over 1, right 1, and then connect those dots. There we go. Yeah, which one is it? Yeah, it looks like B there, doesn't it? Looks like B. Question, Jeremy.
Slope I have a -2, but I go down 2.
Yes, good. Yeah, let's just do that. What if they had made the slope -2? Yeah, put that over 1, and you would go from your first dot, you would go down 2 over 1. Like that. You would still go right 1, but it'd be down 2 right 1. Exactly. Yeah. Yeah, so if they make the slope negative, we go down. Positive is up, negative is down. That's right. But in either case, it would be right 1, because it's still positive 1 on the bottom. Yeah, exactly. All right. Good. Let's keep going then. All right, so try that one. They're giving me a point and then a slope undefined. So over 8, down 7. Right, so there's our point. So first number's over, second number's up, down for the 2 numbers with a comma. And now what kind of slope undefined, what do we do with that? Good. So you guys just know it. So if you know it, you're good. It's just an undefined, so we just know right away, okay, so it's just a vertical line. We don't even need a second dot, do we? In any dot you want straight above, anywhere, straight below. Doesn't matter. Put any dot you want for the, I'll show you how to do the Math Excel thing. Any dot, it's going to be a vertical line. We know undefined slope is vertical because it's infinite slope, really, huh? Infinite slope. So let's go do that one real quick. I'll do that one on Math. All right, let's try that one. So put the dot on the graph. One, two, three, four, five, six. So over 6, and then up, down, so down 4. So over 6, down 4. There's our dot. And now, what kind of a line do we make there? Slope 0. That's a horizontal line, right? It's because it's 0 over 1 if you want. No rise. No rise, right? Slope is rise over run. What kind of line doesn't rise? Horizontal. It's a flat line. Doesn't rise. Yeah. So then, same thing as the last one, except it's horizontal instead of vertical. You just put a horizontal line through that dot. Is that good? Seeming easy? Not too bad? All right, ones here. X equals -4. So they're asking, find the slope if it exists. So this is weird. Normally they give us like points or a picture to find slope, right? That's what they've been doing so far. They'll give us like, you know what I mean? They'll give us like 2, 3 and -5, 7 or whatever and say find the slope. And we'll do the y2 minus y1 over x2 minus x1 thing. Normally, that's what we've been doing for slope, right? Or they'll give us some graph and a couple of dots, you know, with a line, and we'll go, okay, down and over, rise and run to find slope. But now they're giving us an equation. That's different. See how they're giving 3 different settings in which we find slope, right? They've given us, you know, a couple of numbers, 4 numbers, 2 points, 4 numbers. They've given us pictures, find slope. Now they're giving us an equation. How can you just take an equation, like x equals -4, and from that, with no picture, no numbers, find the slope?
There's no slope.
Right. You just know. You just have to remember at that point. Yeah, remember when there's only one letter, it's special. It's either straight up and down or straight sideways. Which one is this one? Yeah, this one is a vertical line. Remember when there's only x? You could graph it if that helps. X is -4. 1, 2, 3, 4. Back at -4. There it is on the x-axis, right? Back at -4. It's a vertical line. You don't have to graph it, you know. But anyway, it's a vertical line, and vertical line is slope undefined. So that's all you got to do. There's no plugging in numbers. There's nothing to do. There's just things to remember. If it's only got x, you could graph it, and it's a vertical line, so it's undefined. Is that good? So it's good to put that in your 3x5 card, you know. Only x, undefined slope, vertical line. Those all go together. All right. All right. So the slope of the line y equals 4. Try that one. All right. What kind of a line is this? Y equals 4. Yeah. Yep. So you just put a line up there at y equals 4. You don't have to draw a picture, but if that helps you, it's a horizontal line. And what is a horizontal line? Slope is 0 because there's no rise. Right? So vertical is undefined slope. Horizontal is 0 slope. So we would choose this. Slope is 0. Does that make sense? Horizontal line, slope 0, no rise. Vertical line, slope undefined. All right. Real life application kind of thing here. Okay. Mountain road rises 40 feet vertically over a horizontal distance of 600 feet. What is the slope? When the slope of the road is written as a percent, it's called a grade. What is the grade? Oh, okay. All right. So how are we going to do the slope of that road? What is the definition of slope? Slope is made up to describe things that are real. What did we make up? Rise over run. So how much does that road rise? Yeah, just 40 over 600, huh? Now, they want a fraction for the answer to part A, and then in part B, we'll use our calculator to get a decimal. So let's do the fraction first. So that is a fraction, but we got to reduce that fraction, don't we? Yeah, so first, let's take it slowly. First, I would probably divide by 10, so cut off a 0. Top and bottom be 4 over 60. Good to there so far? Just divide top and bottom by 10, cut off a 0. And then, reduce it further, divide by 2. You could actually divide by 4, it'd be quicker. And then one more time, and it's 1/15. One step. Yeah, straight to it. Yeah. If you have the Casio Natural Display, you could just hit the button and it'll simplify for you automatically. So there we go. So 40 over 600 reduces to be 1/15. So that's the slope. What does that mean? I mean, real life, what does that mean? That means as you're driving on this road, every time you go up, remember it's rise over run, right? Rise over run. Every time you go up 1 foot, every time you go over 15 feet, you rise 1 foot. Does that make sense? As you're going along this road from one point to the next point to the next point, every time you go over 15 feet, you'll go up 1. Over 15, up 1. Over 15, up 1. Over 15, up 1. That's telling you about how fast you go up. 15 feet sideways for 1 foot up. 15 feet sideways for 1 foot up. That's what that means. And now, part B, they're going to say, give us the grade, and they mean a percentage. And so you just take your calculator, 400 divided by 600, on your calculator. And I'm not a human calculator, so I need the answer.
You do whatever 15 times 100, which is 6.6, and you turn it to 7%.
Okay, you could do that while you're doing some fancy stuff. You could just divide this on your calculator. So what is this? So it's 0.0666, is that what it is?
Yeah.
So I'm discerning from what you said. I didn't figure that out myself, but I can tell by what you said it must be that decimal. And then what do you do with a decimal to turn it into percentage? 2 places, huh?
Yeah.
So 6.666% now that I moved it 2 places. And they want it rounded to what? What did they say? Does it round to
The nearest
tenth?
No, sorry, nearest whole.
Whole? Oh, okay, yeah. So just like you're saying, that'd round to 7%. Right? Because 6.6 is closer to 7 than 6. Good. Yeah, you did the multiply by 100 thing. That's good, too. That just does the decimal movement automatically. Good, that'll work, Elizabeth. Either way. Is that good? So really, you can just divide on your calculator, get the decimal, move the decimal 2 places, and round it. It's a 7% grade. Is what this. You ever see those roadsides that say such and such percentage grade?
Yeah.
Right? What does percent mean? Let me make sure. Let me try to make that a little more real for you. When people say percent, I just separated those words.
Over 100.
Yeah, because how long is a century? 100 years. How much is a cent? 1/100th of a dollar. So cent means 100, doesn't it? So percent means per 100. So when we say something is a 7% grade, or 7% of the class got A's on that test, that means 7 per every 100. That means, right, or you go to a ball game, you're looking at those 40,000 people, 7% of the crowd's wearing hats today. What does that mean? 7 per every 100. If you could break the crowd up into groups of 100, there'd be 7, spread out the hat wearers evenly, there'd be 7 in every 100 that are wearing hats. That's what that means, right? 7% means per 100. So when we say that something has a 7% grade, we mean 7 per 100. Remember what slope is? Rise over run. So that means as you go 100 feet sideways, you go 7 feet up. 100 feet sideways, 7 feet up. That's what a 7% grade really means. For every 100, you're going up 7. For every 100, you're going up 7. Right? Which is the same about as 1 for every 15. It's about the same. 15, 1, 15, 1. Two ways to say the same thing. Make sense? I want this to come home to real life for you a little bit, because I think we remember it better.